Hi, these are the answers for the A2 Chemistry CCEA Fact File for topic 5.5 Transition Metals. So question 1, just going to get up my highlighter. So vanadium is a typical transition metal. Explain in terms of electronic configuration what is meant by a transition metal. So what you need to say here is it's an element which forms at least one stable ion with a partially filled D subshell. You could say it's an element with a partially filled D subshell, but that includes the ones that we don't count as transition metals, like zinc, so you're better off with that definition about the ion. Okay, B, vanadium has a variety of oxidation states. What is the electronic configuration of the V2 plus ion? So what I would always advise here is write out the configuration of the atom first, and remember the electrons which are lost first are coming from the 4s subshell, so there are 2 being lost there. So the actual configuration of the ion, the V2 plus ion, is 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. The atom would also have 4s2 on the end. And you can write it as the noble gas configuration if you want. So then complete the table, giving the formula, oxidation state and colour in solution of some vanadium ions. I would say it's really important to know the colours of the different oxidation states of vanadium. So for V2 plus, it's easy, it's +2 and its colour is violet. The one which is yellow is the +5 oxidation state, and the ion is VO2 plus, and don't forget the AQ in brackets. And then we have the VO2 plus, which is +4 and it's blue, and then V3 plus is just +3 and it's green. Now you could work those out, I suppose, if you hadn't learned them. It's easier just to learn those, particularly because you're learning the colours, so associate the colour with the oxidation state, and then you can remember which ion it belongs to after that. So this one's about a complex. It says the hexa-aquachromium 3 ions, CrH2O6 3+, readily react with EDTA 4- ions in a ligand replacement reaction. So what term is given to ligands such as EDTA? Well, it's hexadentate. You could also have said polydentate or chelate. But hexadentate means it has 6 sites which can form coordinate bonds in the complex. Write an equation for the reaction taking place between hexa-aquachromium 3 ions and EDTA ions. So here it is. CrH3O6 3+ plus EDTA 4- gives us then CrEDTA- and 6H2O. So the chromium hasn't changed oxidation state, it's still +3, but because EDTA is -4, the overall charge in the complex is just -1. Then in terms of entropy, explain why the reaction takes place. Well, when you look at this, there are actually more molecules on the right hand side. There are 7 on this side, whereas there are only 2 here. So because there are more molecules on the right hand side, that increases the entropy. Remember, entropy is the degree of randomness of a system. Another table here, complete the table to give the colours of the metal ions. So we have copper 2, which is blue, chromium 3, which is green, cobalt 2, which is pink, and iron 3, which is yellow. Now, number 4, which one of the following applies to the ligand substitution reaction shown? So the ligand substitution reaction here is the hexa-aqua-nickel complex and En, and forming a nickel-En complex and water. And it's a bit like the one we saw on the last page. In terms of entropy, with 4 molecules on the left and 7 on the right, so the entropy is increasing as that reaction proceeds. The oxidation state, the nickel is +2 in both cases, so that means the oxidation state isn't changing, or the coordination number, sorry. So when we look here, it has to be D. Alright, number 5. Which one of the following gives the ground state electronic configuration for the copper atom and the copper 2 ion? So I've just written here to the right hand side, the copper atom itself is 3D10 4S1, and that's the bit which is unusual because you would expect it to be 3D9 4S2, but one of those 4S electrons gets put into the 3D subshell to make it stable. So the ion then, you take away the 4S electron and one of the 3D ones, and we end up then with 3D9, and that is D there. Number 6, 1,2-diaminoethane or AN is a bidentate ligand forming stable complex ions with transition metal ions. Explain the term bidentate. So bidentate means it forms 2 coordinate bonds with 2 lone pairs. Hexaquanickel 2 ions react with AN in solution. Write the equation for this reaction in which all the water ligands are replaced. So I think actually that was higher up the page, it was. So NiH2O6 2 plus 3En gives NiEN3 2 plus 6H2O. And explain why this ligand replacement takes place. Well, it's because the entropy increases because there are 4 molecules on the left and 7 on the right. Thanks for watching.